Okay, I've done a video on some of our logical connectors. I want to cover the last two logical connectors in this video, and that is the arrow and the double arrow. The double arrow will be pretty more straightforward once we have everything in place. Okay, so the single arrow, right? A arrow B roughly means if A then B, right? But with a very specific meaning of if then. Okay, we don't mean like what's sometimes called the subjunctive or counterfactual. If the Giants had drafted a quarterback, then they'd be more successful. Right? That's something else. This is called material implication. Let's just think about this with Ann and Bob, right? It's the statement, if Ann is here, then Bob is. We're not saying that that's a law of nature, that that's some universal connection, or that, or doing these counterfactual things. We're just saying if you find Ann in the house, you'll also find Bob in the house. We're not saying what we call the converse. We're not saying if Bob is here, Ann is here, and that's key for how we reason with these statements, right? If Ann is here, then Bob is here. And the material idea, right, means it's in the situation we're saying as long as the first thing is true, we're saying the second thing is true. We're not saying anything else about those statements. You know, you found an animal in a park. You're not quite sure what it is, and you say something like. Well, if it's or you see something in the park, you're not sure if it's an animal, and you're like, well, if it's an animal, then it's a cat. Well, of course, that's not something that applies all the time. You're just saying as long as the first thing is true, the second thing is true. You're not saying as long as the second thing is true, the first thing is true. So order matters here, right? If Ann is here, then Bob is here. If I get a raise, I'll buy a car is a very different sentence um, uh, than reversing that. If I buy, I'll buy a car only if I get a raise. Would be the way of reversing that. Right. So the relationship doesn't work. If Ann is here, Bob is here. Maybe Bob's here without Ann. Is how this works. Okay. Was that for all you've said in that statement, right? But as long as Ann is here, you're going to go on to assert Bob is here. So you're not saying they're both true. You're not saying even either one is true, but you're saying if the first is true, then the second is true. And that's all I'm saying. If the first is true, then the second is true. Then that's all I'm saying. Since that's all you're saying, there's only one way for this to be false, which is row 2. That the left side is true, but the right side is false. The left side is true, but the right side is false. In that scenario, the arrow statement is false. Otherwise, it's true. Ann and Bob are both here. If someone says, I'm not sure who's here, but if Ann's here, Bob's here. You go in and you see Ann and Bob, that statement's true. You go in and see Ann and not Bob, that statement's false. Notice if Ann's not here, as we say, the issue is moot for that kind of statement. The issue is moot. So you wouldn't go back out and say, you were wrong, Ann's not here. I didn't say Ann was here. I said, if Ann is here, Bob is here, right? So if the if condition is not met, we like to say, then the conditional is true, right? Material conditionals, like you there was a scenario, right? You wake up the next morning, you don't know what happened, right? If the Celtics won, then they're the NBA champions, right? You wait and you find out they didn't win they lost game 4. Okay, well, both sides are false, right? But that's okay, right? So the statement, your original statement's not false. You said if. Okay. So notice what happens here. Whenever the left side is false, the whole statement is true. And whenever the right side is true, the whole statement is true, right? So you have to see it's not that you're not saying that Ann and Bob both go together. You're saying if the left side is what we call the antecedent and the right side is what we call the consequent, okay? As long as if the antecedent is true, the conclusion has to be true. Okay, but otherwise it's moot. So these statements are true as long as if the antecedent is false, no problem for the statement. And as long as the consequence is true, whether the antecedent is true or not, same is true. The only get it if you have a true antecedent, though, you've met that if condition. The the um, the consequent better also be true. So when the antecedent is true, you have to have the consequent. If you don't, then the statement's false. If Ann is here, then Bob is here. Only false when Ann is here, but Bob is not. Okay? There's actually a parallel we talked about with argument, right? So in argument, we could say, in a valid argument, if the premises are true, if they're true, not that they are true. If the premises are true, the conclusion is also true. We'll don't hold too much on that, but actually we're going to draw on that later in the term. For a lot of people, this is unintuitive. It's just unintuitive to see false and false equals true, and why is that, or the false antecedent. But I've tried. We can go back to it. I'd like to, we'll reinforce it, but at the end of the day, you have to see that this is what we mean by the arrow. It's actually equivalent to saying either, if Ann is here, Bob is here, is actually equivalent to saying either Ann is not here or Bob, otherwise, if she is here, Bob is. So you can actually, and we'll look at that equivalence later in the term. I won't belabor it now. But if you see that equivalence, maybe the chart can make more sense. If it doesn't click, though, you have to learn the chart, right? This is the rule. An arrow statement communicates, these are the rules. True implies true is true. True arrow false is false. False arrow true is true. False arrow false is true. Okay, I tried to make it intuitive with that and Bob, and then we'll go from there. Now, a double arrow B means, remember order matters? Well, the double arrow says each implies the other, right? Each implies the other. If Ann is here, Bob is here, and likewise, if Bob is here, Ann is here, right? So you see the arrow going both ways. What that comes to is actually intuitive, more intuitive, right? It says both, it's equivalent to saying both implication statements are true. A implies B and B implies A. Don't worry if these symbols are looking a little more complicated, right? But you actually have the tools for this. A implies B and also B implies A. What that comes to is that they have the same truth value. You can't have one without the other. So what that comes to on our chart is pretty straightforward. When they're both true, the statement is true. When they're both false, the statement is true, right? Because and if you think of drawing an arrow both ways, false arrow false is false, false arrow false is true, and then false arrow false going this way also true, right? So, and then same thing here, true arrow, true, true. Okay. So when they have the same truth value, the double arrow statement is true. So it's like a combo of the arrow statements. And if they have different truth values, the statement is false, right? If Ant's here but Bob is not, you can't say double arrow. So there's a couple ways. There's a couple ways to think about the double arrows. One way is just equivalence. A is equivalent to B, same truth value. There's other notation symbols where it's represented by a triple arrow, kind of like an extra equal sign. A equals B, same truth value. Could be true, could be false, but same truth value. If you want to think about how this works with the double arrow, just think, right, this is true when both arrow statements are true. A implies B, but also B implies A. Right, so when we say they're equivalent, we're saying if Ann is here, Bob is here, and likewise if Bob is here, Ann is here, and if Ann's not here, Bob's not here, and if Bob's not, right, we're saying they're equivalent, right? This is stronger than this, right? This statement, right, just says Ann implies Bob. It doesn't say the reverse. Bob implies Ann, right? We can get a sense of, go back to the single arrow, right? We get the sense of how the order matters by thinking about what it means to meet certain conditions. In another logic text I used, right, you can get in trouble. There's a Um, the example is, if she loves me, then she calls me. Right? So there's a big difference between if she loves me, then she calls me, and if she calls me, then she definitely loves me. Right? Call implies love. Right? So, right, you make a bad inference, say, oh, she called, therefore, right, that would be a bad inference because there might be other reasons for calling. Okay. So that's one of our old examples. Right. It's a little misleading to think about this with um, like geometry, but it can help you see, right? If it's a square, then it has four sides, but not if it has four sides, then it's a square, right? Um, um, so then that'll always hold, but that gives you the sense of the order. Okay. Um, the last thing to note in this video, it kind of applies to both videos, is that we can use these symbols, right? So when you use these symbols, you create a new statement. So if you use an arrow to join two statements, you have an arrow statement. But then, as I've kind of shown, now that can be treated as a single statement with a single truth value and combined with other statements. So you can have like um, uh, um, it's you have these building blocks to make even more complex statements. You can say, um, you can say uh, either A and B are both true, or C is true. Either Ann and Bob are both here. Otherwise, if that's not true, Carl is here, right? And again, the or means maybe all three of them are here, right? So you can start to build compound statements. And then in another video, I talk about how do you interpret when you have multiple connectors, when you have compound statements combined with other statements, and you can get more complex from there, as you'll see in the exercises. So we will go from there. Okay, but that gives an overview of symbols, and these symbols, all they do is again create statements with a new truth value based on the truth value of their parts, right? So that's the key takeaway here. From this, you can start practicing exercise set 2A. What exercise set 2A does is it takes these statements and asks you to say, well, if here's the truth value of the capital letters, what's the truth value of the larger statement? But I have other videos kind of talking through how you're going to work through that, but I wanted to make sure we had the foundation. Okay.